Hello and welcome to Science. Hello and welcome to Science Never Stops with the U.S. Space and Rocket Center. My name is David and I'm the Planetarium Director at the U.S. Space and Rocket Center, the Intuitive Planetarium. And happy birthday, happy 30th birthday to the Hubble Space Telescope. Tonight we are going to take a look at Hubble's highlights. 30 of my favorite pictures that Hubble has taken over the last 30 years. And it's going to be all sorts of wow and awesome. All right, so as we're waiting for a few more people to jump in, let me zoom in a bit, and we can get this party started by taking a look at Hubble's brand new image. Let me square this up for you a little bit. Bring this into view. Very cool. And while everyone's tuning in, feel free to let us know where you're watching from. We'd love to know. And see which place has the most viewers. So again, for those just tuning in, this is a happy birthday, happy 30th birthday to the Hubble Space Telescope, which really has revolutionized the way that the things that we understand about astronomy, for one, but also how astronomy sits in the public's eye. Because in the past, astronomy has been has been very difficult to get into from the standpoint of equipment and from the standpoint of really seeing and easily understanding what we're looking at very far away. So it's not something that was extremely flashy by any means, and it stayed a good bit more with the astronomers who worked at night, as you can imagine, and wasn't something very much in the forefront of public knowledge. And with the advent of space telescopes being able to get outside of the Earth's atmosphere to get a much clearer view of what's going on, not have to deal with any of that atmospheric refraction and scintillation and these sorts of things. Basically, the atmosphere distorting the light in some way, we're able to get a much clearer picture. We're able to keep things that are very, very big, very cool, and very steadily pointed at something, and get these really, really nice images. And Hubble in particular, again, launched 30 years ago, or deployed 30 years ago today, is really the most prime example of something that has changed the field of astronomy, in that looking at this picture that we are right now, I mean, this is amazing. This is a cloud of gas and dust, which we call a nebula. It's a star-forming region, and this is situated in the Large Magellanic Cloud, which is one of the three things that you can see in the night sky that are actually not in our own galaxy. It's a dwarf galaxy, about 160,000 light years away. It's not visible from the Huntsville area, nor anywhere in the United States. This is only visible in the southern hemisphere, but it's this sort of like fuzzy patch in the sky if you look with the naked eye. But if you look at something like the Hubble Space Telescope, let me zoom back a bit, this is what we can see, and as a very wide field of view that was taken by ground-based telescopes. And then zooming in, this is the brand new picture from Hubble, which shows all sorts of exquisite detail, and I'll zoom in on this in just a second. Looking to the comments, we have a question that is from Natalie, or from Angelina, excuse me, that is, how many pictures has Hubble taken? And at this point, it's had over 1.4 million exposures, or million observations, rather. So that is a tremendous number. It's working around the clock 24/7, literally the last 30 years, except for a few different maintenance things and that sort of thing. But for the most part, it's worked nearly nonstop for that time, and 1.4 million observations and a tremendous portfolio to show for it. So I want to go into a little bit of detail about this picture, and then I have my 30 favorite or 29 other favorite pictures from Hubble from the last 30 years for you. And I'm not going to spend too much time on any of them. If you have more questions about anyone in particular, you can ask them in the comments and I can get back with you after the presentation. But I want to sort of rapid fire through these so that we can show you lots of wow and awesome over the next 30, 40 minutes or so. All right, so this one in here is called the Cosmic Reef Nebula, and so named because it looks sort of like a coral reef, sort of like brain coral in here. And what we're looking at in the center of this picture, I realize that my pointer's on the wrong screen. There we go, sort of brain coral in here. In the center of the screen, we have these very, very young, hot, and massive stars. So we're talking in the 10 to 15 or 20 times the mass of the sun, probably 15,000 to 20,000 Kelvin. So you're looking at very, very hot compared to about 5,000 Kelvin of the sun. And in terms of the colors that we see in this nebula, the blues are going to be due to oxygen that is ionized by ultraviolet radiation from these stars, and the reds are going to be due to hydrogen and nitrogen that are ionized. And then the different structure we see in these clouds is due to cosmic radiation, basically very charged particles that are streaming out in these stellar winds that are sort of carving out different folds in this nebula. And then in this bottom corner, this is actually, the blue region is actually the result of a single star that we see in here, and it has shed off its outer atmosphere, outer atmospheric layers, and is ionizing them. That's why they're illuminated just like the other part of the nebula. And this is a Wolf-Rayet star, which is actually probably going to explode fairly soon in the next few million years, and is about 200,000 times brighter than the sun, which is a lot. So these stars are very volatile, they're very, very bright, they're very, very hot. They don't last very long. They make very pretty pictures in the sky, so that's all cool. And again, this is in another galaxy, not the Milky Way. This is the Large Magellanic Cloud, and it's about 160,000 light years away. Cool. Okay, so let's get rolling. The software we're using too is called Worldwide Telescope, which is available for free at worldwidetelescope.org. And I have a lot of preset things in here, but you can reproduce this if you so desire and play around on your own at worldwidetelescope.org. So the first thing we're going to go to is Hubbles Object. And actually, so I double-clicked, which jumps us there. I'll single-click for the other ones to give us a nice journey. But let me zoom out just to give you a sense of perspective. I'll keep all of the constellation lines on so that you can see where we're situated. And this one is near Bode's the Herdsman, which is visible now, actually, or tonight. And zooming in on this, this is not something that you can see with the naked eye, and really nothing we're going to see tonight is something that you can see with the naked eye, short of maybe two things. But this is a very strange setup in here where you have this sort of concentric ring of the outer part of this galaxy and the sort of spherical center in here. So you have a very densely packed old core in here, and you have a much younger outer ring, and then what appears to be very little material in between, and I don't really know what's going on in here, and that's really funky. Further funky is that there appears to be the same sort of scenario kind of at your 1 o'clock in here, far in the background. So it's not associated with this at all, but is in the image, and that's sort of neat. So very, very funky. So yes, you could say, Colin, that it is in a galaxy far, far away. I agree with you. All right, so continuing rapidly, we're going to go to M106 in here. And so with this nice single click, we can take a journey a little bit more smoothly in here, give you a sense of where we're going. So M106 is within the constellation Ursa Major, the Great Bear, and I find this one very, very beautiful. This is a spiral galaxy, and we're going to look at a lot of spiral galaxies. When I was preparing for this, I realized that I really, really like galaxies, simply because these pictures from Hubble especially are just so high in resolution, so that when we start to zoom into these images, you can really see all these little individual dots, which are not pixels, but rather stars themselves. So that's a really powerful thing. So in all of these galaxies, or most of these galaxies, we're going to see cores that are very yellowish, and that is indicative of a much older population of stars. In the different spiral arms, when they're spiral galaxies, we'll typically see these sort of darker brown or reddish regions. And these are going to be different gases, dust, that sort of thing that is blocking the light from nearby stars, but they're also, if they're dense enough, they're star-forming regions. And this is stellar nurseries, just like what we saw in that Cosmic Reef Nebula picture that was released today for Hubble's birthday. And then the bluer regions are typically going to be very hot, young, energetic stars. So these are going to be stars very unlike the Sun in that they're very massive, they're very hot, 3, 4, 5, 6 times hotter than the Sun is, and maybe 5 to 10 to 50 times more massive than the Sun. They also have life cycles that are much, much, much faster. So the Sun is going to last for, maybe 9 to 10 billion years or so. These stars are on the order of maybe 100 million years, perhaps less, depending on the star, I guess. Some could be as short as maybe 10 million years, maybe some are about 1 billion years, somewhere in that region. There are also stars that are cooler than the Sun, smaller than the Sun, that last much, much longer, hypothetically 1 trillion years, maybe longer than that. All right, so continuing on, you'll notice that this in here says that it's the Bug Nebula. It's also known as the Butterfly Nebula, which is maybe the more popular term. And the Bug Nebula in here, I think, is just a really stunning picture. So what we see going on in here is something very, very neat. You have this stellar remnant. This is the death of a star in here, and it is something that is being ionized by this sort of stellar remnant, where you have lots and lots of material streaming away, and again being energized by what's left behind. It's a planetary nebula, so this means that it's not something that has been, it's not a star that's gone supernova, that's literally ripped itself apart, but rather is in the sort of end stages of its life and sort of spewing off its outer atmosphere, and then again the remnant is energizing that, so it lights up and looks really pretty. So that's a fun, neat thing to look at. And the sort of structure is not something that's extremely understood, but it is seen in multiple places. This sort of bipolar nature, sort of biconal sort of thing, and again, quite neat. So we're going to back up and continue on. I should point out that this is in the constellation of Scorpius the Scorpion, and this will be visible in the summer. Again, not to the naked eye. And most of these would be hard to see with a small telescope, if even visible at all. So we're going to go on to an object that has a terrible name. This is ARP 273, and ARP 273, that's the catalog that we're looking at. It is a pair of interacting galaxies, and let me zoom in a good bit more. And actually, let me highlight one other thing for you too. I can actually crossfade this image off to give you a sense of sort of the background imagery that we have. And this serves to give you a very nice idea of what our imagery looks like without something like Hubble, right? So these are ground-based observations. This is the digitized sky survey, and that's fine. We can tell that something's here, and it's very, reasonable, and it's very cool. But without something like the Hubble Space Telescope, we can't get this impeccable detail that you see in here, where 300 million light years away, you have these weird spiral galaxies that are sort of, at this point, not extremely strongly interacting, but this one is sort of about to get probably ripped apart. And the result is almost like a rose, or a sort of question mark that's formed, and very, very pretty. Also, anytime you see these stars that have the little sprites on them, those are typically photobombing in the foreground, just so you're aware. Okay, continuing on. We're going to travel from the constellation of Andromeda near Aquarius and Capricornus. So the Helix Nebula is another planetary nebula, and where the Bug Nebula or the Butterfly Nebula, we're sort of looking at it from the side. Where are my hands? There we go. We're looking at it from the side. In this case, we're looking edge-on into that cone shape. So we're able to see all sorts of really pretty things in here. You can see that stellar remnant at the middle. So this is something that's blown off its outer atmosphere once again. And we can also see these little features going on in here. And these are globs of matter, material, gas and dust again, that are a little bit thicker than the rest of the regions, and they are persisting a little bit more. They're enduring a little bit more than the rest of the material, which is sort of being energized as it's getting pushed away by these stellar winds. And so you can see all sorts of really cool features in here, and it looks sort of creepily like an eyeball. The bluish color in here, I believe, is due to oxygen, and then you get into hydrogen and nitrogen in these reds, helium in these yellows, if I'm not mistaken. So keep the Helix Nebula in mind, because we're going to see something similar to that, which is not that, a little bit later in the presentation. Okay, we're going to jump to M81, which is again situated sort of near Ursa Major, the Great Bear, which is visible in the north. So James asks, so the clouds we are seeing are the result of stars exploding. What causes them to do that? So in some cases it's the result of stars exploding, and in some cases it's the result of stars dying less explosively. It's stellar death either way. So a supernova we'll talk about in a moment, but these planetary nebulae, which is very much a misnomer because it doesn't have anything to do with planets, but it's the result of a star that is sort of running out of fuel and begins having a big fight with hydrostatic equilibrium between radiation pushing out and with gravity pulling in. And so when you have less radiation pushing out, there are my hands again, small window. When you have less radiation pushing out, gravity can pull in a little bit more fiercely. This causes a lot more temperature and pressure. That causes radiation to ramp back up due to fusion. That pushes out again, and you sort of have this sort of pulsing effect, and the result is that atmosphere gets blown off, stellar material gets blown off, and then illuminated, and it blows off a lot of its atmosphere, and eventually runs out of fuel and sort of smolders out. So that's how a planetary nebula works. We'll get into a supernova in a moment. Looking at M81, this image barely makes my top 30 because it's only a half, and that's frustrating to me. But the half that we have is so good, because you zoom into this, and this is about 12,000 by 12,000 pixels, and all of these little points are all stars in here. And how beautiful is that? But perhaps more striking to me is the galaxy that's right next door. So this is M81, called Bode's Galaxy, and this is the Cigar Galaxy in here. So we're going to jump over to the Cigar Galaxy, M82, and M82 has all sorts of neat things going on. These two galaxies are gravitationally interacting, and so the result of these galaxies interacting is that M82 is stealing material from M81. So literally gas and dust are being pulled from M81 to M82, and that material is falling onto the existing galaxy and causing increased stellar birth. It's actually called starbursting. So much more stellar birth is happening than normal, and that's a very exciting thing because it means lots of young stars and very interesting to look at. So we can zoom into here and get all sorts of interesting details near the core with these thick gaseous clouds, these thick nebulae in here. And these are all really prime regions for stellar birth, especially in these redder regions, sort of above and below the plane of the galaxy in here. So very, very neat stuff going on. And I find the picture very striking. Continuing, this is going to bring us to the Bubble Nebula. Okay, so the Bubble Nebula is in the constellation Cassiopeia, and it's basically the result of a sort of bow shock almost from the stellar wind from this central massive hot young star. And it's near this sort of giant molecular cloud, and the result is that radiation from this hot star causes that material surrounding it to glow, just sort of like what we're seeing in all of these cases. So that's sort of the standard conversation with things in space, is that we can see them because something is energizing them, whether it's themselves energizing themselves, or being energized by something else. So typically that's, or really that's the only way that we can see energy. And when we can't see something like dark matter, for example, it gets a lot harder to study, and we have a lot more questions, and that's very difficult. So another question from James is, if these are obviously static images, but if we were viewing them from within the galaxy that they're in real time, how fast would all of these particles be moving? That's a great question that I don't have an answer to off the top of my head. I would say that it very much is circumstantial. Some things are incredibly, incredibly quickly. We have a picture that has to do with jets in a little bit, and those are moving at a significant fraction of the speed of light. Other things are moving not so fast, but it also depends, on sort of your relative positioning and what you're basing that speed around. So I don't have a good answer for you at all. Cool, good talk. All right, continuing our conversation, we're not going too far away, sort of near the constellation Pegasus, and this is a funky picture. So this is neat to me, not because it's visually amazing. It's certainly not one of the high resolution ones of Hubble, but it's cool because it is something that actually has 5 galaxies. So this is Stefan's Quintet, and what we're looking at are 5 very tightly knit galaxies in here, and we can see various different structure. We have an ellipsoidal galaxy, spiral galaxies in here, an irregular galaxy in here, and these are all sort of, some are close together, some are sort of transposed from our perspective, and it's just a lot of galaxies that are in a very nice perspective from us and looks awesome. So continuing. Suzanne says that her 8-year-old daughter wants to know why there is a purple star. And I'm sorry that I missed that question in real time, so I don't know where you asked that. But the purple star could be a combination of things. It's either the result of the way that these images are colorized, or you can have a purple star if it is hot enough. So in stars, temperature corresponds to, or color corresponds to the temperature of the star. And the hotter the star, the more blue into purple it's going to get. Typically, we don't see purple because there's still a significant amount of blue, and that's more sensitive, or our eyes are more sensitive to it. So there. But purple stars, UV stars can exist as well, but we typically see them in other wavelengths, just less strongly, perhaps. Okay, this right in here is a supernova that is known as NGC 5189, and I honestly don't know very much about this, and I intentionally didn't do a lot of research on all these things so that this presentation wouldn't be 2.5 hours long with excruciating detail. But I do want to give you an idea of what a supernova is. So there are a few different ways you can have a supernova occur, but perhaps the most easy to understand is what's called core collapse. So we talked about hydrostatic equilibrium, which is where radiation is due to nuclear fusion, which is where hydrogen is exploding and forming helium. This is lots and lots and lots of energy release. This pushes radiation out. Hydrogen producing helium, very, very powerful. Also powerful is gravity with all this mass of a star that pulls in. So fusion radiation pushes out and gravity pulls in. So these things sort of temper each other and they're more or less good. As you get a more massive star that gets hotter and hotter and hotter, it can fuse heavier and heavier and heavier elements once they are made in the first place. So you can fuse heavier things like carbon, you can fuse things like nitrogen, and so on and so on and so on, until you get to iron. And the difference is once you get to iron, which is a ways up the periodic table, once you get to iron, it actually requires more energy to fuse than it puts out. That's the first element to do so in this chain. And so as soon, literally the split second that iron starts to fuse, it takes over the whole thing, and the energy output is consumed fully in trying to make iron, and all of that radiation pressure pushing out stops. And so in that instant, gravity takes over and everything smushes together really tightly. And at a subatomic level, you have protons and electrons coming very close. They really don't like that. They release a tremendous amount of energy and everything blows its guts all over the place, and it looks beautiful like this. Wow. So that's very cool. Whenever we reopen, you can come visit the planetarium, and we have a really sweet visual of what a supernova looks like. All right. So there's a question from Colin that says, earlier you mentioned that 1.4 million pictures have been taken by Sir Hubble. What percentage of those pictures are as exciting as the ones you were showing us? Ooh, also a good question. I guess that depends on your general excitement level. And that would vary from person to person, but I would say they're all exciting in different regard. Some of them are like spectra observations, so you're not necessarily going to get a beautiful picture, but you're going to get a good understanding about your target composition-wise, variety of different parameters, right? So like where it's located, how fast it's moving relative to other things, these sorts of things. So those sort of observations are very important. They give you good understanding, but they don't necessarily look pretty. What percentage look pretty, I don't know, but there are very, very many. It was very hard to narrow it down to 30. I was sitting here late last night with my wife, and we had, I don't know, like 70 pictures and just chopping all these beautiful things. So I narrowed it down to about 35, and then I got sad when I should have been getting excited. So that's all right. Okay, but talking about getting excited, this is one of my most favorite pictures of Hubble, and people who've been to the planetarium have probably seen this in one of our shows. This is the Whirlpool Galaxy, also known as M51. This is a beautiful, beautiful representation of a spiral galaxy. Not barred spiral like our galaxy, but more just a spiral. Very, very distinct spiral action going on in here. You can see the older stars in the center, those yellow stars. You can see these thick dust lanes, which are nice star-forming regions. That's what we see with these reddish areas are stellar nurseries. And then the blue stars are these hot young stars that have just been born. And then you've got this funky looking like stingray kind of tail on the end, bob on the end. And this is a separate galaxy. So this is actually something that is getting gravitationally ripped apart by the Whirlpool Galaxy and essentially consumed. So this is something that does happen in space. Things are moving around very quickly, and some more than others, I suppose, to go back to a previous question. And even though space is very, very big, you can have things collide with each other through mutual gravitational interactions. And typically the bigger thing wins, as you might expect. But what that looks like is that when you have two things colliding, you don't actually typically have stars collide. It's actually less likely for any two stars to collide than to have a single star collide when galaxies collide. But the dust does collide, nebulas collide, and the result of that is heavy amounts of radiation. So it's not good for you to have be in a galactic collision. That's pretty dangerous in my experience that I don't have. But yes, that could be quite bad. You'd get cooked. Further, the gravitational perturbations could cause your star perhaps to get flung out of the galaxy, and then you're in space alone, and that's no good. Or maybe you could get flung away from your star. That's really no good. So lots of mess. But wow, what a beautiful picture. Very cool. Ooh, we've got a question. Can you show us our galaxy? Not yet, but maybe if time permits at the end. We don't have a picture of our galaxy with Hubble simply because, or not from the outside at least, simply because we're inside of it and you can't get outside of it because it's enormous. All right. So we're looking through our galaxy to see these other galaxies. This one is also near Ursa Major, but is technically residing within Canis Venatici. Okay, one more galaxy in here, M104. This is known as the Sombrero Galaxy, and you've doubtless seen this at some point in your life. Ooh, another good question. How do we know, this is from Julie, how do you know that they're colliding and not just one behind the other? That's a great question, and it's based on a few different things. You can do some very fine-tuned sort of Doppler shifting, so you can get distances based on the light that's coming towards us from these different galaxies to figure out how far away they are. And so if you say, hey, well, this one's 15 million light years away, but this one is actually 25 million light years away, then they're not gravitationally interacting. So that's one way you can tell. The other way you can tell is simply visually if they are seeming to be ripped apart or not. And in some cases they are, and in some cases they aren't. Some cases they look like they're being ripped apart, and they're just superimposed. We'll see a picture like that in a minute. So very good question. We could go on about that for a while, but there's not time. So the Sombrero Galaxy is a representation of a spiral galaxy that we're looking at from a different perspective. So again, finding my hands. So for example, galaxies are typically pretty disc-shaped, right? So you could look at them like this, like we saw with the Whirlpool Galaxy, or you could look at them like this, like we're seeing with the Sombrero Galaxy. We're sort of kicked by a little bit. So our galaxy, for example, the Milky Way, is about 100 to 150,000 light years across, but it's only about maybe 1,500 to 3,000 light years thick. So very thin by comparison to how wide it is across. Further, our galaxy gets up to maybe 10,000 light years thick in the galactic center. So there's sort of like it almost looks like a fried egg, sort of in the middle. Or I guess the whole thing looks like a fried egg where the yolk is in the middle. Or a pancake with a dollop of butter, if you prefer that. I like eggs better than pancakes. Ooh, Natalie asks, how many galaxies has Hubble discovered? And so many I don't have a good answer for you. Wow, that's a lot. That's a Google question. Okay, so leaving the Sombrero Galaxy, we're going to head to M57, which is the Ring Nebula. This is something that you can find with a small telescope fairly, I won't say easily, but with some determination because of the constellation Lyra that it's in. And I'll show you that in a second. But the Ring Nebula is another planetary nebula where we're looking sort of edge on into this cone, and it looks, wow, a heck of a lot like the Helix Nebula. They're not the same thing. They're almost impossible to distinguish unless you're really, really attuned to what they look like, because with a different processing job, then the colors might be tweaked a little bit one way or the other, and that they look very, very similar. But and they are similar. It's the same process where this is a planetary nebula. The star is shedding its outer atmosphere near the end of its life, and then it's being illuminated. To find this, if we look at the constellation Lyra, the lyre, it's a musical instrument, sort of like a mini harp almost. Vega, this star in here, is very, very bright, one of the brightest stars in the sky. And this is a nice parallelogram that's decently bright in the sky that you should be able to find as well. So if you go to the end of the parallelogram, you have about 60%, 40%. So you're sort of like a 60-40, and you're closer to the one that's closer to Vega on the sort of end that's farther away from Vega. And so you should be able to point the telescope in the right direction. It's just whether you get it fine-tuned enough. And yeah, not too miserable to find. Sometimes slightly frustrating. All right, going a little bit further away into a constellation that's pretty prominent at this time of year. We're looking at Corvus the Crow in here, which has a very funny story associated with it. This is the antenna galaxies, or galaxy in here. And what we're seeing here is the result of a galaxy that was collided with in the past, I believe. I'm going to pull this up and make sure I'm not making this up. But the different colors we're seeing sort of hold true again. This darkish, brownish, orangish material is going to be thicker star-forming regions. The bluish material in here is going to be these younger stars, and there are a lot of them you can see in here. And this is because, okay, so it is a pair of interacting galaxies, and what's pretty exciting is that they are causing some star bursting because of all this much more energetic gas, basically, from these this collision. So that causes a lot more energy, a lot more densely packed gas, and allows for stars to form a good bit more readily. So that's pretty cool. The nucleus that you can see in here is sort of forming into a single one giant galaxy, and they sort of dance around each other in this like funky form. If you're bored later, or at some point, you should watch simulations on YouTube of galaxies colliding. It's very, very pretty. If we get some time in the future, maybe I'll put that in the planetarium. So hold me to that, and it'll be really cool. All right, continuing on. Move away from this. Ooh, this picture is relatively new, and it's very pretty. You can go onto Hubble's site, and you can actually take this apart in the different chemical constituents. This is a good opportunity for me to look at the different ways that we deal with color. So when you're looking at these different Hubble pictures, it's important to realize that the color is not always represented in the same way. So it's not necessarily always the true color that you're seeing. So sometimes color is based on using different filters aboard Hubble. You use a red filter, and then we color it red. Use a blue filter, we color it blue, that sort of thing. And that's fairly true color. But sometimes we can use different sort of chemical analysis, and then you color things based on what chemicals we're looking at. So in this case, that's basically what's going on. Where the different colors correspond to different chemicals that we see in this nebula, and it's beautiful. This was actually the 29th anniversary picture from Hubble, and the green is due to oxygen, the yellow is due to hydrogen, the orange is due to nitrogen, and the red is due to sulfur. So that's not what color these things make, but these are the colors that have been assigned. And they're sort of the colors these things make, but they're the colors that have been assigned to give you this spectacular picture, which is super, super cool. Okay, zooming away. All right. And actually, I didn't point out that that was likely the result of two stars that were sort of spinning around each other and interacting and sort of pushing off their atmospheres. One of them is shedding its outer atmospheres. All right, so moving on, this is M33, and this is the Pinwheel Galaxy. Let's see. We are in the northern hemisphere still. Good. Okay, so this is the Pinwheel Galaxy as opposed to the southern pinwheel. Oh, excuse me, this is the 1000 Ruby Galaxy instead. I'm getting all confused now. Okay, so again, we can see a spiral galaxy that's a little bit less defined. So while some of these pictures look very similar, they're also they are also a little bit different, and that's sort of what makes the images from Hubble so unique and exciting, right? We have you know, some stark similarities, some very significant similarities, and rather some very stark differences throughout the universe. And so when we look at these things with Hubble, it gives us an awesome opportunity to get an understanding of, you know, compare and contrast. And we can see that many similarities are occurring, but we can also figure out all sorts of fun things going on that are different from place to place. So again, we still have these same dust lanes. We still have these same star-forming regions and older areas near the center. And it's pretty standard that the core forms first, and then the spiral arms form afterward. And then it's thought that after a spiral galaxy has collided with something else, another galaxy perhaps, or has aged significantly, then they sort of become ellipsoidal, sort of an egg-shaped, and stellar birth slows very, very much dramatically. Those pictures are a lot less exciting in my opinion. Okay, continuing on. But you can see that those spiral arms were a good bit less distinct. Okay, we're going to jump to another one of my favorites. These are all my favorites, but my favorites. So this is part of the Valon Nebula, and so actually this is the Valon Nebula. This is what's called the Cygnus Loop. This whole region here, it's quite large. As we zoom in a bit closer, you can see the difference between the background imagery and the segment that Hubble has picked. This is actually a shockwave from a supernova that is traveling through space. So this is not a very recent supernova, but one where we can see this outer shell from the explosion sort of bow shocking as it propagates through space. And it's sort of compressing all this material together. And that is where this energy to illuminate this is coming from for the most part. So very, very pretty. It's so pretty, I'll show you, it's also my background to my computer that you can see in there. So fun stuff. So this is what you would call one of my favorites of the 30. Shelby just asked, does every picture have the same color assignment coding? No. So if you want to, and that's sort of what I was just talking about, you have to literally look picture by picture to get an idea of how color is assigned. And if you go to Hubble site, which is the NASA-run site from the Hubble Space Telescope, that one is gives you some inclination, but the European Space Agency, the ESA run one, which is spacetelescope.org or .org, I believe. That one has typically what different wavelengths are being used and what colors are assigned to those and that sort of thing. So it gives you a little bit better of a rundown. Okay, so earlier there was a question about how do you know that two galaxies are not just superimposed from our perspective, and in this case they are. So these two galaxies look like they're colliding, and they aren't. They're not very close at all, and that's really cool. So this one is in the foreground, this one's in the background. They're separated by a distance that is Googleable, NGC 3314, and they look awesome. I'm getting a little bit verbose, so we're going to carry on. This one, very cool. So far we've looked at mostly nebulae, mostly galaxies. And this is something a little bit different. This is a stellar cluster. This is a globular cluster. And it's, I think, the second brightest one that you can see in the sky. It's very, very pretty when resolved. We have tens of millions of stars in this cluster. Very, very tightly knit, very dense. Globular clusters are going to be very big. They're typically outside of the galactic plane, and they are going to be very, very old as well, compared to open clusters, which would be something like the Pleiades, the Seven Sisters that we can see with the naked eye. Those are on the order of thousands of stars and a good bit, a good bit younger, like very, very young. Cool. Continuing, we're going to head to the Eagle Nebula. And I have to confess, so this is one of the most popular Hubble telescope pictures really of all time, and it's something that has been improved upon as years have gone on. Certainly Hubble had plenty of difficulties at the beginning with chromatic aberration and that sort of thing, and that was significantly improved, and improvements have been made to increase the capability of the instruments and that sort of thing. So we've been able to add on and on and on and refine pictures better and better and better. So this is within the Eagle Nebula, and these are the pillars of creation. These are star-forming regions. They are significantly large. They have young stars that are hiding behind these huge pillars of gas and dust that are bursting out, and how awesome is that? And I really like this picture. I think it's very cool. But maybe it's the overall hype. This is not one of my favorites. This is just in the favorites. Fair enough. Okay. Continuing. I should point out that you can find all of these things on Hubble's website, hubblesite.org, or you can go to spacetelescope.org. Both of those are reasonable options and should get you what you want to see. All right, let's see. So this picture in here is called the Harrow Jet, and this is very funky. Let me zoom in on this. If you go to Hubble's website, the article about this is all about how this picture was taken just in time for the 7th Star Wars to come out, and that's great because it looks like a cosmic lightsaber, and it very much does. So what's going on in here? Obscured by this dust, you actually have a jet of material coming out in both directions from this newborn star. And the way these jets occur, you basically, they can occur in different ways, but typically it's due to a very strong magnetic field with a rapidly rotating star. And the way the electromagnetics works, the rotating star has basically gets these particles to sort of get focused towards the poles and then streamed out, beamed out, almost like a cosmic lighthouse, so to speak. And so, similar to a pulsar, these things are spewing jets out at a significant fraction of the speed of light. These very energetic protons and electrons are streaming out into space and blasting away at the nebulous material from which the star formed. And even though this image is pretty low in resolution compared to most of the other ones, we're looking at about 1K by 1K, or 1K by 1.2K, compared to a lot of these others are maybe 10K by 10K. It's still an awesome picture. One that I think is really cool. All right, backing up on this. Now, this is also, so we were in Orion in here, and we don't have far to go because we're going to jump to the Orion Nebula, which is also arguably one of the most popular Hubble pictures. It's an amazing picture. This is like 18,000 by 18,000 pixels square. Very, very cool, very, very detailed. You can see the difference of very washed out versus all sorts of beautiful details. We can see, if we back up a little bit, this is the famous trapezium, these 4 very bright stars that we can see brand new, very young, in this nice stellar nursery region here. We can see darker regions that are thicker, lighter regions behind that are being illuminated by these new young stars. I mean, this is pretty much awesome. I would say this does fall into my favorites, and is awesome. If you come to the planetarium, you will see this in the planetarium often. Very pretty. We're going to jump over to something, oh, and you can see that with the naked eye too, if I didn't say that already. So that's pretty much the only thing in this presentation that you can see with the naked eye. And it doesn't look like that, to be fair, but it does look pretty awesome. Now this, I already had these things turned on, so it actually sort of was a bit anticlimactic. But let me rotate this picture a little bit. so that it gets you into a region that you're more familiar with. Because if we look at this right in here, this is this very, very classic picture called the Mystic Mountain picture. And so this is sort of Lord of the Rings-esque, I guess, and just a beautiful, beautiful nebula, very similar to the Pillars of Creation, very, very beautiful. And this picture is often seen standalone, but what people don't realize is that it's just this smaller portion of the Carina Nebula, which has all sorts of things going on. This is the whole nebulous region in here. This is enormous. But Hubble has this really nice panoramic view as well. And there's just all sorts of beautiful structure. You can see very stark contrast between these really dark, densely clumped nebulous areas. Again, in here with some brand new stars behind them that are illuminating this from the outside. Really, really pretty. The Carina Nebula is also home to the opposite side of things, stellar explosions as well, different supernovae, but just really beautiful structure and something worth exploring. I struggled mightily to get this into the software late last night because it was too big and I had to chop it up into pieces to get it nicely in here. All right, continuing. And thank you to everyone who's saying, love the pictures and the narrator. I guess that's me. Thank you. Thanks for tuning in. Oh no, I clicked the same thing. Let me try one more time. We'll jump over there. Oh wow, this one's awesome. Okay, so this says GUM29. That's an alternate, this is an alternate title to the more popular title, which is called Westerlund II, also a bit of a mouthful. This is something that we have actually on the wall in our hallway on the way into our lobby in the planetarium at the Space and Rocket Center. So this is a neat picture. This is also a stellar cluster in here, but it is interacting with this sort of molecular cloud, this nebulous region next to it. And so you can see lots of stars sort of photobombing in the foreground, this really tightly packed stellar cluster in here. And again, some really beautiful structure, beautiful colors. This is something to look into more on your own time. So Westerlund II, that's what you want to check out. And you can get an idea of more of what's going on in here in great detail. So I told our social team that I'd probably go about 30 minutes to benefit the bedtime of my 2-year-old, and that's not happening. But that's either to your benefit or not, depending on if you're enjoying this. We're going to continue on. And more rapidly, I think, since we're approaching an hour. Looking at this, this is another supernova. I thought it was awesome because it's just really pretty. Stellar guts spewed all over the place. It looks a good bit like the Valon Nebula because they're similar, both supernovae remnants, and how cool is that? Continuing in the interest of time. That one's also in the southern hemisphere, so not something that you could even attempt to look at with a telescope unless you're the person who's in here from Australia. And then go for it. This is a neat picture too. So this is a great opportunity for contrasting the angle that we're viewing these different things. So on the left side, we're viewing edge on into this galaxy. There we go, there's my hand. On the right side, we're viewing more sort of top down or bottom up, however you want to look at it. They're both spiral galaxies. And the one on the left appears to be a bit older. When you don't see as much blue, then you're typically looking at older stars, unless they're doing colors in a more enhanced and less true color, true to the naked eye sort of, or the aided eye, I guess, sort of fashion. All right. Jumping to another one of my favorites. This is in Taurus the Bull, right on the edge. This is the Crab Nebula, also known as M1. The Crab Nebula is a beautiful representation of a supernova. This is something that exploded in 1054 AD and was visible to the naked eye on the Earth, and now 1,000 years later we can see that that really bright point in the sky has now expanded out into space and looks amazing. And these little tendrils are just beautiful. On my computer, actually, I have a few monitors set up, and one monitor is better than the others. and the monitor that it's really good on. These tendrils are so sharp, so I hope you're viewing on something like that. It looks amazing, and if you're not, go look this picture up when you have something better to view on. So again, one thing that's a little bit hard to see in here, and actually I'm going to go look into our context bar in Worldwide Telescope, which is on the bottom, and take a look at some combined X-ray data, which is not from Hubble but from Chandra. There's actually a pulsar in the center of this, a pulsar remnant, and this is a spectacular view. You can see those jets emanating away from it, sort of down to the bottom left corner and up to the top right corner. And this is the result. This is that stellar remnant, that the sort of core of the collapsed star that is fully neutrons at this point because the protons and electrons smush together, spinning incredibly rapidly and causing a stream of particles to go out, and that's serious. All right. So that is in my favorites. That might even, that's very close to my favorite. That's like top 3 for me. All right, going to M101. This is the one that I was confused about, and you'll see that M83 and M101 are very similar indeed. M101 is the Pinwheel Galaxy, not to be confused with the Whirlpool Galaxy, not to be confused with every other spiral galaxy, and the southern pinwheel, which we'll look at in a moment. So this one right in here is a little bit less, I guess, consistent in its spiral arms. They're still very nice. They're very pretty. We can see all sorts of beautiful stars in here. Again, getting yellower as you get to the center. Wow, that looks amazing. But they're a little bit more jagged on the outside, and that's just the way some galaxies are. It's very hard to tell if these are the result of some sort of gravitational interactions in the past, or if it's simply the way they gravitationally interacted with themselves, that sort of thing, simply because the time scales that we're looking at are so tremendous, and the physical scale of distance is so tremendous in space. Very hard. Okay. Now, we are coming to our very last picture of the evening. Let me make sure I'm not making that up. Awesome. We're going to jump to M33, and this is my favorite. So if the Crab Nebula is number 2 and the Whirlpool is number 3, and maybe Orion is number 4, M33, the Triangulum Galaxy, is my favorite. And if you've been to the Intuitive Planetarium, this is typically what you walk into in the dome, simply because it shows off our projectors in amazing splendor. This picture in here has been cropped from the observations. It's the second largest picture that the Hubble Space Telescope has ever taken. It's not a single picture, but rather many exposures mosaic together, which a lot of images are from Hubble, but this is many. This picture is about 25,000 by like 39,000 pixels. And the only thing that's bigger is its close neighbor, which is the Andromeda Galaxy, which is about 25,000 pixels by about 75,000 pixels. So huge pictures. Things that make your computer struggle a good bit. Anyway, what's awesome about this is that when we zoom into this picture, talk about stars. This is amazing. Each one of these little points of light is not a pixel, but rather a star. And I actually did have to shrink this image because it's a few gigs and it didn't like that. So I had to chop it up a little bit, and we're not even viewing at full resolution. If we were at full resolution, you'd be able to see that this star is not the same as this star, because this is a foreground photobombing star. This and this and this are all galaxy clusters, or sorry, star clusters in another galaxy that's 2.5 million light years away. So wow, that is so cool. We can see this spiral structure is a little bit less defined, but it's very pretty. And we have some really neat regions in here. So I've added a couple high resolution patches so that we can go in a little bit further. This is a gaseous star forming region in one location. And then down here is a particularly significant sort of molecular cloud region in here, and you can see lots of young hot stars in here, as well as some really dark, thickly packed clouds. very, very dense nebulous material in here. It's also really neat that we can, go from the sort of outside in, and as we do so, we can see all sorts of types of stars, but we get collectively denser packing of stars as we get closer towards the core, and that's quite apparent in these images, which is quite beautiful. So it's this is not something that was really the initial intent with Hubble to explore, pictures of this images that have this sort of breadth of angular resolution in the sky. But oh no, it looks like I've broken. Let's see. That's not good. Well, we may be broken. Either way, the point is, this is an awesome picture. This was not the original intent, and it looks awesome. And Hubble has really transformed how we as scientists and we as the public look at astronomy and what we know about it. And it is an amazing tool for science, an amazing tool for astronomy PR because of how simply awesome it is. So with that said, happy 30th birthday, Hubble. Keep on sticking in there and doing great stuff. We hope to give you a successor soon, but keep you functional for quite some time regardless. Thank all of you for joining us this evening, and join me again next week, next Friday at 7 p.m. for something else awesome. So with that said, remember that this is Science Never Stops with the U.S. Space and Rocket Center. My name is David Weigel with the Intuitive Planetarium. Have a great evening. Good night.